Let's solve this question. There are two circles C1 and C2 of radii 3.6 and 9 units. The transverse common tangent T touches C1 and C2 respectively at P and Q. The line joining the centers of two circles intersect P at R. The distance of R from the center of smaller circle is 6 units. Then the length of PQ is. First of all, let's just make the diagram for this problem. So C1 and C2 are two circles having radii 3.6 and 9. So this is circle C1 and this is circle C2. This is C1 and this is circle C2. And these two circles have radii of 3.6 and 9. Now the transverse common tangent. I know for these circles there are two types of tangents. One is direct common tangent and second is transverse common tangent. Transverse common tangent is the tangent when I join the centers of two circles, and if when I join centers of two circles and this line intersect the tangent, then that tangent is transverse common tangent. And if this line joining the centers of two circles does not intersect the tangent, it is called direct common tangent. So if I join this line connecting the two centers, this is the line. So I have to draw the tangent as this line because I have to cut the line joining the centers. So the transverse common tangent would be this, right? And this transverse common tangent touches C1 at this point P and C2 at this point Q. It is given. And it intersects the line joining two circles, centers of two circles at R. This is the point R. Now connect these 2 points. I know when I connect the center of circle to the point of tangency, this length becomes perpendicular to the tangent. So when I join this line also, it is perpendicular to the tangent, right? I am calling this point as A, center of circle C1, and calling this point as B, center of circle C2. Now there are two right angle triangles. Obvious thought comes into mind is of similarity, right? What is given? That radii is this length. This length here is radius of this circle C1, which is 3.6, calling it R1. And this is the radius of this triangle C2, R2. It is given as 9 units. Also, it is given that the distance of R from the center of smaller circle, this length AR, is given as 6 unit. This is 6 unit. Now, I have to find the length of this transverse common tangent. I have to find the length of PQ. To find the length of PQ. Now, similarity comes into mind. So take triangle A, P and R. This is triangle APR, right angle triangle, and take triangle BQR. This angle is 90 degree, APR. Similarly, this triangle BQR is also 90 degree. Okay, and this angle, let's just call it theta. It will be equal to this angle because these are vertically opposite angles. Two angles are equal in these two triangles, so we can say that triangle APR is similar to triangle BQR by angle property, or third angle would be 90 minus theta, and same here third angle would be 90 minus theta. Now if these two triangles are similar, so we can say the ratio of their corresponding sides would be equal, right? And the corresponding sides would be the side equal to angles which are equal, right? So first I have to write those sides which are given. So side opposite to this theta in smaller triangle is AP. So the corresponding side would be side angle to theta in this triangle, which is BQ. So AP upon BQ must be equal to side opposite to 90 degree in smaller triangle is side opposite to this 90 degree angle in this triangle, smaller triangle APR is AR upon side opposite to 90 degree in this triangle BQR is BR, and the same is for 90 minus theta, corresponding side would be PR upon QR. Now these lengths are known. AP upon BQ. AP is given as 3.6 and BQ is given as 9. So we can say the ratio of these corresponding sides would be equal to 3.6 upon 9, which is equal to 18 2 times and 18 5 times. So the ratio of corresponding sides of these two triangles is 2 upon 5. Now AR is given as 6. If AR is 6, I can find BR. It must be equal to, the ratio must be equal to 2 by 5. So 6 upon BR. I can get the value of BR as how much? 15. So I get the length of BR as 15. Now this triangle BQR I know is a right angle triangle and two sides are known. Hypotenuse is 15, perpendicular is 9. I can get the value of this base using Pythagoras theorem, or if I know the triplets very well, I can directly find this side, right? This is 5 into 3, this is 3 into 3, so I can say it's a 3, 4, 5 triplet. So this side would be 4 into 3 is equal to 12. So the length of QR is 12. Using this ratio, I can find the value of PR, because I need to find the value of this length PQ, and it is equal to PR plus QR. QR is already known, 12 units. PR I can find from this ratio, PR upon QR is equal to 2 by 5. So PR would be equal to 2/5 of QR. QR is 12. Right? So if I add these two, I get this is 24 by 5, which is 4.8. So PQ, the length of PQ would be 4.8 plus 12. It is equal to 16.8 units. So the correct answer to this question would be option D.